All right, dudes and dudettes, let's do some exponents. You probably will need to have this guy in front of you. This has all the different exponent rules. So you got product, quotient, all that stuff. I'll reference those from time to time. And then we'll go over this as well. That's the other part of the notes. 14 little example problems like that. You've seen all this stuff in Algebra 1, probably even did some of it in geometry as well. So you've seen all of it. I'm hoping you remember most of it. Um, but anyway, let's get started. So on the left-hand side, I have all the rules. So this is, your product, quotient, power to power, all that stuff. So each red one is the next flap, and then the blue ones are just two examples for each one. I'll briefly hit them. Feel free to pause or whatever so you can write it all down. Um, anyway, so the first one, product rule. Anytime you're multiplying two things that have the same base, you're going to end up adding them. So m plus n right here. So 7 plus 8, 15. 3 plus 21, 24. We don't change the base at all. So that was adding. We're going to, when we divide them, we're actually going to subtract them. So m minus m. So 15 minus 7 is 8. 18 minus 15 is 3. So then we get to the power to a power, and this is when we start multiplying. So m to the n. So just like here, 4 to the 5, 2 to the 21st, we're multiplying. So 4 times 5 is 20, 2 to the 21st, 42. Please notice that I have kept all my bases the same throughout all the problems. X's stay there, H's stayed. Let's see what else we had up here. 3's, X's, 3's again. All my bases stayed the same. Next one. We have an exponent outside of two things. So I think this one was product to a power because we have two things being multiplied, a times b to the power of m. It's just kind of like distributing. So we distribute the m to the a, m to the b. So 3x to the 15th, qg, it doesn't matter, whatever the letters are, to the 34th. We're just going to distribute it. So 3 to the 15th, x to the 15th, q to the 34, g to the 34. Next thing is a quotient to a power. Same idea, we're still going to distribute, except we have a fraction here. It's called quotient to a power as opposed to product to a power because it's being divided instead of multiplying. The answer to a multiplication problem is a product. The answer to a quotient or to a division problem is quotient. So we distribute, so 2 over 3 to the 6th. That gives us 2 to the 6th, 3 to the 6th. Same thing with y and x. Next one is a super duper easy one. Anything raised to the 0 power is 1. So r to the 0, 55 to the 0, a million to the 0 is all just 1. Don't get mixed up with that. It's not 0. It's definitely 1. The last two are probably the hardest ones and the most we see everyone struggles with. Anytime you have a negative exponent, this is like saying this is over 1, okay? So then we flip it around, and a to the m is in the denominator without the negative. This is not a typo. Negative m and then positive m. So x to the negative third is 1 over x to the third. 5 to the negative 5 is 1 over 5 to the 5th. And then reverse, if we have 1 over a negative exponent, that becomes a to the positive exponent. So 1 over y to the negative 7th because of y to the 7th. 1 over 2 to the negative 15th becomes 2 to the 15th. All right, those are the rules. Let's do a couple examples and then we'll be done. All right, so we have our problems here. 1 through 4 just want us to identify the base. So the base is the part that's being raised to the exponent. So number 1 is 2. Number 2 is just x. It's just this part. On number 3, it's the 2x, and number 4 is the negative 2x. So it's whatever's being raised to the exponent. Number 5, we know that the negative means it goes in the denominator, so 1 over negative 5, and then the negative part goes away, so then my answer is 1 over 25, because the negative 5 is squared. Number 6, same idea. 1 over 5a all squared, so that's 1 over 25a squared. Number 7, only the a is to the negative, so I keep my 5 up there and then move bottom, so 5 over a squared. Number 8, anytime you got a fraction, we flip it, so that becomes 3 halves squared, which is 9/4. When you raise 3 squared, 2 squared. And then the last few here, they're a little more challenging. They look menacing, but they're really not. Number 9, multiply 3 times negative 4, that gives us negative 12. And we're at, negative 12, sorry. And then z and z, that makes 9 because we add them. On number 10, kind of two ways to go about this. We could distribute. So I got y to the third, z to the 9th, we're multiplying, z to the 15th. Then we got to reduce this. So y to the third over z to the sixth. Wherever the bigger number is when we subtract, that's where it stands. So 15 minus 9 is 6, but it stays in the bottom. Speaking of bottom, negative means this goes all going in the bottom. So 1 over negative 2, a to the third, b all to the third. Then I need to raise it all to the third. So negative 2 to the third is negative 8. Then we're multiplying. 3 times 3 is 9, b to the third. All right. Number 12 works the same way. Number 13, we need to add those together. We keep the base the same, and then I'm going to add 6/5 and negative 5/3. I'll let you find the answer to that one, but I'll tell you it's common denominator. So you got to figure out what a common denominator is between those two fractions. Hint, it's 15. And lastly, number 14 is like an ogre or a layer, or a layer. I just give it away. It's as layers. So I multiply. So a to the 3, because 3 times 1 is 3, over 18. Then times negative 12, so that gives a to the negative 36 over 18, which reduces down to a to the negative second. And 1 over a squared is our answer. Good luck. Exponents are tough, but I believe in you. Bye-bye.